blow through here early
4 hours a day.
The following program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
And welcome to the Weather Classroom. Today we're going to be talking about seasons. That's our focus. Of course, there's 4 seasons out there: fall, summer, winter, and spring. But today, in specifics, we're going to take a closer look at summer and winter, the 2 seasons there. And what causes the seasons? Well, we have the sun, and the earth rotates around that. And as it rotates, we get the angle of the sun just a little different, and it changes. Charlie Welsh gives us more details on what's going on with the 4 seasons.
The Earth is heated by the sun. The amount of heat reaching the Earth from the sun changes as the Earth's axis tilts toward or away from the direct rays of the sun. Different areas of the Earth are warmer or cooler depending on that tilt. The Earth's axis is tilted toward the sun in the northern hemisphere around June 21st. This is when summer begins. While we're having summer, people in the southern hemisphere are having winter. The Earth's axis is tilted away from the sun in the northern hemisphere about the 21st of December. This is the beginning of winter, but it's the first day of summer in the southern hemisphere. The fall season begins on or about September 22nd in the northern hemisphere. On this day, the sun's rays shine directly on the equator. But remember, folks in the southern hemisphere are enjoying spring. Spring occurs in the northern hemisphere around March 21st. The sun's rays are still shining directly on the equator. Therefore, for people in the southern hemisphere, it's autumn.
Again, the big significance of the tilt of the Earth is what helps us make our seasons. For example, as we move into the summertime of the year, the northern hemisphere, we're tilted more towards the sun. As a result, we have the warmest time of the year, and our revolution around the sun is in summer. But just the opposite in winter, as the northern hemisphere is tilted away from the sun. As a result, we end up getting some chilly conditions in wintertime in the northern hemisphere. The angle is the most important aspect of this. Let's check out more with Bill Keneely.
In late December, the sun is at a low angle to the horizon for the northern hemisphere. Therefore, the sun is not above the horizon for long each day. The nights are longer and the air is colder. The sun's energy doesn't have as long to warm the atmosphere. But by early April, there is approximately a 30-degree difference in the angle of the sun at midday. This allows for longer days and more sunlight to warm the air. Also, because the sun is at a higher angle, its energy doesn't bounce off the Earth's atmosphere as readily. In winter, that bounce effect also keeps the sun from keeping us warm. By June, the sun is 17 degrees higher in the sky. Besides longer days and less atmospheric bounce, the sunlight is also more concentrated. The concentration is much like holding a flashlight straight above your hand and then holding it at an angle to your hand. Overhead, the light is concentrated. However, at the angle, the light falling in your hand is less concentrated and not as bright. Bill Keneely, the Weather Channel.
All right, so we go from wintertime over to summertime here. And actually, did you know that during summertime, the Earth is actually farther away from the sun than it is during the wintertime? So it's not the distance to the sun, it's the angle. So if we look a little bit closer, what happens on the summer solstice, whether it be June 21st or June 22nd, we get the more direct sunlight, and therefore the sun can warm the northern hemisphere much more so, and that warmth turns into heat and humidity, and hey, that's summertime. But it also means swimming pools. Terri Smith tells us more about the heat of summer.
It's easy for your body to become overexerted or overexposed in the summer. Any outdoor activity in extreme heat or humidity can put your body in danger. Fortunately, though, your body will tell you when it's had enough. The symptoms of heat exhaustion mean that your body is dehydrated and is having problems removing heat. By recognizing these symptoms and cooling off right away, you can solve the problem of heat exhaustion. Whatever you're doing, stop, relax, and rest in a shady spot. Drink plenty of water. If you ignore the warning signals your body gives and continue strenuous activity, it could prove fatal. Heat stroke is the next possible stage after heat exhaustion, when your circulatory system is under too much strain. Get medical help right away and try to lower body temperature quickly. You can prevent heat stress by using common sense. Listen to your body and trade in that lawnmower for a hammock in the shade.
As Keith just alluded to, we talked about summertime when the Earth is tilted towards the sun, but in winter it's just the opposite. The northern hemisphere, where we, the United States, spend our time, would find it tilting away. In fact, places up around the Arctic Circle, like Point Barrow, Alaska, do not even see any sunlight hours, anywhere from the middle of November to the middle of January, because it's tilted away from the sun. And boy, we can get those real cold outbreaks of air sliding across the United States this time of the year. In fact, to refresh your memory, let's look back at a blizzard that occurred in 1993. The winter storm of March '93 began as rain, thunder, snow, and sleet across Texas, Louisiana, and Mississippi. By storm's end, 250 people were dead, and the storm's impact was felt from Cuba to Canada. Earlier in the week, forecasters started to identify the ingredients that would create this massive storm. The first, a very big late-season Arctic outbreak plunging across the United States. Secondly, the warm, humid air in place over the Gulf of Mexico, Florida, and the Gulf Stream. Last but not least, a very big dip in the jet stream, coupled with disturbances aloft, helped carve out immense clusters of thunderstorms. By Friday, the winds in the Gulf of Mexico had increased to hurricane force. Water began to batter the coastline of northwest Florida. By early morning, the storm surge reached 10 feet in places. The beach communities of Taylor and Dixie counties were awash in water. Waves and debris crushed homes, tossed cars, and destroyed lives. 500 structures were destroyed, another 500 damaged. Other areas in the state were pounded by a tremendous line of thunderstorms, which brought down trees and power lines from Tallahassee to West Palm Beach. The center of the storm howled northward into the southeastern states. By early Saturday morning, the storm reached blizzard strength. Impassable roads left motorists stranded. Snow and vicious winds closed down entire cities. Birmingham, Alabama reported 13 inches of snow, and some Atlanta suburbs had 10. Property damage was immense. Buildings collapsed under the weight of the snow. Hundreds of hikers in the Smoky Mountains had to be rescued as the blizzard moved in. 300 miles away, fierce winds crashed into the entire length of the Carolina coast. As the storm moved to the northeast, the tremendous snows continued. Pittsburgh measured 24 inches, and even areas accustomed to winter storms had record snows. Syracuse reported 43 inches. Airports were closed down all along the eastern seaboard. Roads were jammed with jackknife trucks and abandoned cars. Whole areas were paralyzed. By the time the storm was done, 26 states had been hit and 50% of the nation's population affected. A truly memorable event for those who experienced the March storm of 1993. I'm Dennis Smith, the Weather Channel. Today we talked about seasons. That all-important tilt of the Earth is what makes up the difference. Is in the summer months tilted towards the sun, allowing more solar radiation to heat up the northern hemisphere, while in winter it's tilted away. We get the cooler air masses and much cooler conditions in the United States. It's about seasons. Check out Chapter 2 in our Weather Classroom book.